Hey, hello students. This is Algebra 2 Unit 1 and now lesson number 9. So the question is, lesson name is what's the equation? So the goal of this lesson is let's define sequences, and also I can represent situation with sequences. So that means a lot of examples. I'll go straight away to the student's task which shows here what's the equation. See? So 9.1 they gave you. So So in 9.1, okay, so this is the equation. And you can remember this is explicit formula. So last class we have seen this in the lesson number 8. What is the meaning of explicit formula? Where where the value at any step number, that means, oh here let's go straight away about it. What is this? You're supposed to do mentally, right? So it's like in this example, you plug in x equals 0. So 0 goes right here in the beginning. That's what it is. Now, without even mentally, by just looking at it, last class, remember that this number, last time we had a paper with 8 by 10, and the total area was 80. And therefore, we written down area at any times. In the beginning, it was 80. And then you go on taking off the strips of, I'm sorry, you cut into two. It becomes like this. Again, it cut into two, it becomes like this. And we remember because you cut, the area becomes half. And how many times do you make that half? So this 80 is the beginning. So by just looking at this is 32 without even calculation, right? And then what is the meaning of this one? Means you make one. It's like, oh, in this it is in the beginning. It's first sheet. It is 3 by 2. And then what that the next is the ratio that you see, the 3/4. So it's like you're going to make 3/4 of this 32. So 3/4 of 32, and 4 divides 32 8 times 8 times 3 is 24. So this is 24. And again you do, now you're supposed to do mentally, right? So first one is 32. Now if you try to see 32 basically means 8, 8, 8, 8, and 8. In your mind you can think like this and say, okay, this, and 3 8. So 3 8 become 24. And the next one you make 24, break it into 4 more pieces because that's what you have here, 4. So 24, if you break into 4 pieces, it has to be 6, 6, 6, 6. But we want 3 of them. 1, 2, 3. So 6, 3 will be 18. You can also do actual work. Okay. So you can also do from here to go here. It is 3/4 of 24. So 4 crosses out 8, and 8 times, I think, sorry, 6. 6 times 3 is 18. And that's how you do this. Okay. And if you want to figure out all of them, so what was the first one? 32 was the beginning. Then you take 3/4 of it, which was uh, uh, let's do this. So remember it was 8, 8, 8, 8, and you have this 3 is 24. Next you do break into 24. This was 32. Now it is 24. And it is 6, 6, 6, 6. So 3 of this will be 18. So that's like 18. And the next one is you have 18 and break 18 into 4.5, 4.5, 4.5, 4.5. So this 3 will give you 4.5. 4.5 plus 4.5 is 13.5. I only hope. So this is how. So the synthesis of this is mentally is can student understand that you can know that on the table, if you want to make a table in the beginning, if this is we used to use and then fn, right? Now I can use x and f of x. So that means when x is 0, 1, 2, and 3, in the beginning it is, so in the beginning it is 32, and you multiply 3 4, so you get 24. So how many 3 fourths you multiply? That's the question here, see? So from the beginning, every time you do 3 4, it means from here till here is you do once, then from here you do 2 3 4, and then from here over here you do 3 of them. And that's why there is a variable there, x. This x means this 3 4, how many times is multiplied itself. I only hope uh, it makes sense. Let's go to the next question is about cake. Now look at this. So question number task activity 9.2. There is a cake, a large cake is in a room. The first person who comes, he takes one third of the cake. Then second one takes one third of whatever is left over. The third student goes and takes one third of whatever is left. If you continue likewise, can you create, let's see, n, complete the table. So you have a table here, C. So what does C stands for? C is uh, how much quantity of cake remaining, or the area of the cake remaining. It means if this is the case, so the full cake in the beginning is like, so the full area is like 1 unit. We don't know exactly how much is the area. It could be like 243 maybe square inches. And then we go on making three pieces because there's one third. So anyway, the complete the fraction of the original cake left. So this means the fraction of the original cake left. It means if somebody will try to break this into, let's say, because there's a one, he takes one third. I'm gonna go show these visuals. But you're supposed to write two definitions for one recursive and one non-recursive. When you say non-recursive, basically it means you are going to make explicit, you are going to create explicit formula or explicit definition. So if I take this, mm, mm, so what it means is, make a nice, like this. Okay, let's do like this. So we have n means step number. So 0, then 1, then 2, then 3, then 4. Let's understand this with the help of a actual figure. So n and cn means what fraction is remaining, right? So let me draw this figure. First of all, there is in the beginning. So in the beginning, there's a big, like, see? Now I'm breaking this into three parts. So to break this is the center. This is how it is, right? So when you break this, one student comes. So in the beginning, the area will say, because it is the whole circle, we'll take it as 1. Now, because it's the whole, what fraction is remaining basically means you break this into three pieces, and each one is one third, and one third, right? Now, when you take off this piece, these two pieces, oh, one student takes off this piece, right? So how much is remaining is the question. What fraction is remaining? And you can see what remaining is something like this. Watch this. I'm doing what remaining is something like this. Okay. So this is what is remaining. Okay. So this is the 2/3. It means, so this is that. I mean, this is the one third plus one third, because one third is gone. This whole piece is actually one third plus one third, which is 2/3. So this is gone, right? So it's like you have something like this, and you have this is gone. See? So this piece is gone here. This one is gone. So so now how much is remaining is 2/3. Okay? So that is the 2/3. This is the 2/3. Now what I do next is I break this again into three pieces. So each one will be uh, so basically in the beginning you're multiplying by it's like as good as saying it is two-third, two-third of one. So this fraction that you see here is two-third of one. Now what you do next is I want to do the visuals first. So since I try to break this into three pieces, so another student comes and takes up this piece. So that means each one is how much? So we need to know each one is how much. So this whole thing was two-third, right? And I break this into. So I have to write each piece will be one-third of this two-thirds. See? So it means it is 2 divided by 9. So each one will be 2 9. This is 2 9. And this also is 2 9. See? So this piece is gone. This is gone. So there are 2 plus 9 plus 2 plus 9, which will be 9, and 2 plus 2 is 4. So this is 4 over 9. Otherwise also, uh, algebraically, you're just multiplying two-third of two-thirds. So the previous one was two-third. This is the previous one, and you do two-third. So basically, you do this, and then what is left over is okay. So let's draw a black color to show. So 2/9 and 2/9 is 4/9 this piece. So this part I'm gonna draw right here. So like this is 2/9. This is 4/9. This all the whole thing is 4/9. But I can break this into three pieces. You see? So that means each piece will be how much? So one if you multiply this by one-third, so this will be 4 over 3 times 9 is 27. So this is 20. So each is 4 over 27, 4 over 27, 4 over 27. So another student comes and he goes and he eats this. So how much is remaining is the question. So that means what is remaining is this red color. So it means this red color is remaining, right? So 4 over 27 plus 4. So your plus 4 27 is you can say 8 over 27. So this is 8 over 27. And how do you get also? You can just multiply by two-thirds. So algebraically, each time you just do the two-third of. And again, if I try to break this, okay, so that becomes 27. So this will be 8 over 81, 8 over 81, 8 over 81. So this one is gone, and you get 16. So this becomes 16 over 81 because you're multiplying 2 times 8 is 16 three times. And again, you multiply two-third. So 2 times 16 is 32, and 3 times 81 is 243. And that's how it is. So hopefully I made sense. Now I want to create equations. So what's going on here is let's write the explicit formula. So the explicit formula is so how many times do you multiply two-thirds? That's the Cn equals in the beginning it was the red one, it is 1. And now after that you went on multiplying, you see 1, 2 like this. So you're going to multiply two-thirds, and then the question is how many times? So from here to here you multiply 1 two-thirds, but from here to here you multiply two of them, 1 and 2. Then from here to here you multiply three of them, 1, 2, and 3. And from here to here you go multiply four of them, 1, 2, 3, and 4. And that's why if this is n, if there is an n here, so depending on how many, uh, just to show maybe wanted to show. Okay, so basically this answer that is in this case, this is that C1 because there's a 1. So the fraction of the cake remaining is, it is the 1 in the beginning and 2/3 raised to 1. So if this answer is uh, the cake remaining when the second student eats the 1/3. So it's like 1, so 2/3 raised to 2. If it is 3, then it is 1 times 2/3 raised to 3. So likewise, if it is n, you put n. That's the explicit formula. Okay? And this works for n equal either 0 and also greater. So there is a greater than equal to means 0 and so on. So this is explicit formula. And we can also write uh, recursive formula means from the previous fraction of cake remaining means in the beginning, just like this. So C0 is in the beginning it was 1, and after that, at any time, at n term, it is the previous one, the area of the cake remaining in the previous step, and there you multiply by 2/3. So this is for n is 0, and this is for n is 1, 2, 3 like that. So it is like n is equal to 1 and also greater than. And this piece is called recursive formula. And you're done. So the question was, by now we should know what's the difference between explicit and what's the difference between recursive and explicit. So for explicit, it all depends on the beginning, what number, and then how many times do you multiply these two things. But in the recursive, you have to know the beginning. Of course, that's fine. And then after that, the previous one, this means the previous term is multiplied. Okay, 9.3 is Fibonacci 6 squares. Now, what is this? On a graph of paper, here. Mhm. So on a graph of paper, draw a square of side length 1. So the square means like this. Draw another square of side length 1 that shares the side with the first square. That means if I draw one square, then you draw another square which is shares that one side. See this side? So you have one. Then it says add 2 by 2 with one side along the sides of both the two square. What this means is, so this is a side 2, 1, 2, and you draw another square like this. It becomes, so in the beginning you had first one was 1, then the next green one was 1, and now you have side length. So the first square has got side length 1, second square has got side length 1, third square has got side length 2. So this is 2. So it's like you're adding 1 plus 1 is 2. What is the next one? Next one is you're going to draw another square. This time I'm going to use blue color to show. So this side length was 2, okay, and the previous one, green one, was this. Along with this, this is what I'm going to use. Together 3, so I'm going to draw another square with side length 3 like this. See, so it is 3 by 3. So, so the so the side length is 3. So I'm going to write 3, but 1 plus 2 is 3. See. Now next is you're going to draw one more. Let's use pink color. This time the blue one was 3 by 3, and the one before was 2. So see this 2 and 3. So the total 2 plus 3 is 5, and then I'm gonna make a square with 5. So this is 5. So that ends it is this you're adding 2 plus 3 is 5. And the next one we can do one more. Let me use another color here. So this one is 5, right? So this is 5, and if this is 5, and this is 3, so this also is 3. So 5 plus 3 is 8. So you draw another square with 8 like this. Okay, so that will be done. So this length will be 5. The previous one I forgot to write 8. 8 plus 5 is 13. See? So this is 5 and this is 8. 8 plus 5. So that's what you're supposed to do this on your paper. I want you to really get this piece. Write the sequence that lists the side length, and here is the sequence. And then can you predict the next two terms in the sequence? That means the next one will be 8 plus 5 will be 21. And the next one will be this two will be 24. This together will be 55. This together will be 79, and like that. So it goes on like this. And that's called Fibonacci sequence. So the question is, how we do write the sequence? What I'm saying is, okay, so the sequence starts with 1, then 1. 1 plus 1 is 2. 2 plus 3, 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. This is 21. 13 plus 21 is 34. If you add these two, you get 55. You add these two, uh, 50, 60, 70, 89. So the goal is, this is the first one. Now Fibonacci starts with F. So this is the first sequence. Okay. This one is F1. This is F2. This is F3, and like that. So how do we write the recursive definition? Is in the beginning, first one is 1, and then at any time, f of n, let's say, it's always, is if I want to find this, how did we get this? You added this one and this one. So it means the step number, it is the f of n minus 1, the previous one, plus you added another previous one. So this means one less. I could have made a like this. So this is how I could have made like this table to understand. This is 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like that. But then since I was more curious about this number, this piece. So if I want to know at the sixth position what is number, so you're adding 5 and 4. So if this is F6, this is F6. So the previous one is F5 and the previous one is F4. So see, this 5 is 1 less to 6. And that's why you use if this is n, so you do 1 less here, and then plus, then this 4 is 2 less to this one. See? So it is n minus 2. And this you have to write, 1 is taken care, so that this one will be 2, 3, 4 like that and greater than. So you get a Fibonacci sequence. This is called Fibonacci sequence, and written with the help of recursive formula. Make sense? I really hope. Yeah. So this is little creepy kind of form, but that's how it is. You have to know this is 2 step before. This is 1 step before. So this number is 1 step before. This number is 2 step before. Hope makes sense. I'm sorry, I made a slight mistake here. So I made a slight mistake here. So you are given in the beginning, it is not just this piece. You are also given the second piece. F2 is 1 here. So the first step is 1, second step also is. So these two pieces are known. Then this one goes from 3 onwards. So this is the mistake I did. 3 and greater than. Okay, so that's all you're supposed to do. But the question uh, is it possible? Uh, is it possible to write? Question is it possible to write exclusive formula? Like, can we write f of n equals some kind of in the earlier cases we used to write a of if it is an arithmetic sequence, it is like okay, you have something in the beginning and maybe a of 0, and then every time you multiply the different d times how many times you are adding the common difference rate of change. It depends on this is starting with 0, so this n is n greater than equal to 1. But if you start with a of 1 like this, okay, then you have to write d of multiply. So this becomes n minus 1 here. So depending on this one is the first one is given, but here a1 is given. So you think of so these are confusing, but that's how it is. It's a different approach to write. If you have the beginning one, you just say n greater than equal to 0. But if you have something like this, start with a1, and then you can say here n greater than equal to 1 here. Or I have a one playlist with cool maps. So and there I'm gonna put a video to show that Fibonacci sequence, how to write this expression 1 over square root of 5 like, with a golden rule formula, a golden ratio also it's called 1 plus root 5 over 2 raised to n minus 1 minus root 5 raised to n, sorry. So this is the formula kind of question always arises. How did we get? There was one mathematician named Binet. He tries to show that, and this number that you see is actually 1.618, which is called golden ratio. And golden ratio is what you see in real life. It is being used in painting and even so many. I mean, you see the ratios, which means this basically means it is 0.618, which is 1, and it is like 100% original, plus you are doing adding 61.8%. So that's the golden rule, golden ratio. So check out when I post in the Google Classroom why it is. Right now, let me go to the next one. That is, we wrote. Oh, this is I ready for more if you want to do. So what this basically means is they're asking you, is the Fibonacci say arithmetic or it's none of them because you're not multiplying the same number. Remember, it was 1, 2, 3, 5, like that, 8, 13. So if I want to take uh, ratios like this, if I want to do this, means it is 1 over 1. This means 2 over 1. Like this, this means 3 over 2, 5 over 3, 8 over, and you will always see they fluctuate, they increase and decrease. So this will be 2, this will be, I think, 3 divided by 2, 1.5 divided by 2 will be 0.75. Okay. And then like this, you will see, and again, increases, decrease. You can check, do the inquisitive way of, and you can, what you notice of this sequence, you will see these ratios, they increase, decrease, and they are between like this, 1 less than equal to the ratio, and less than 1. Sometimes it's 1, that's the only case, the first one, but most of the time it is it is 1 less than 2. So it is 1 less than or less than 2. So at the most, eventually, if you go on like this until almost f of, if you try to do more, maybe 23, f 23, 23 or 24, you'll see the numbers doesn't the ratios are almost like same. So if you want me to, so this basically this, so these are the numbers, and you can put on your calculator and see what's going on, and you'll see the ratio. They increase, decrease between one and two. Let's go. We look at this nice example is in the initially. This is the summary what we learned in this lesson. Your paper is size is, let's say this paper is size, and break this into 4, and this is what you see here. See, so it's like 1/4. That's why you see in the beginning it is 80, and then you take the what is remaining is quarter of this, quarter of the previous one. It's still recursive, okay? And then again you break this into 4 pieces. And this is what you have here. So every it is one. So each time you write you take 1/4 of the previous one, or you could also write this equation in the explicit formula. How do we write it? So it is like an equals, in the beginning it is 80 times, and every time you take quarter, and how many times you take raised to, and because it starts with 1, that you have to be very careful, so you write n minus 1. So this formula works for greater than equal to 1. Or you could also write the same formula with 1/4 and raised to n only. That's the time you put equal to 0 and greater than equal to 0. So these are the two different confusing because of this. If the original one you start with the step number 0, you just put an n. But if the original step number starts with 1, like in this example, then this is the correct answer. This is the correct answer. I hope I make sense. Okay, with this, lesson 9 is done. And I hope this really will help those of you who are missing the class. I see a lot of students are absent. And those of you who do not understand the class, you need more time. And that's why I'm making this video. Thanks for watching.